So determine the volume of the solid generated by revolving the region bounded by x equals square root y minus 2, where x equals 0 and y equals 5 about the y-axis. So first thing I'm doing is drawing myself kind of like my picture. So it's being rotated about the y-axis, which means we are integrating with respect to dy. So that's also in part why the equation is given to you in terms of dy. So we are integrating y minus 2 dy. And then if x equals the square root of y minus 2 and we start at x equals 0, then I'm kind of going backwards and solving for my y values when x is 2. So I'd square it, get y minus 2 equals 0, so that when x equals 0, I have y equaling 2. And then again, you could like work backwards even from that. You could say, okay, well, what happens when y is 3? Because if I plug in a 3 for y, 3 minus 2 is 1. So I get the square root of 1, which is 1. So when y is 3, x is 1. So I know that this point is 1, 3. And then it says we go all the way out to y equals 5. So similarly, I'm going to solve all the way out to 5 on y. So that, which is annoying, they picked 5 because the square root of 3 is not like a commonly known number. If they had picked y equals 6, then we'd have gotten x equals 2. So whatever. I read 3 somewhere in here and 2's out there. So then this is making that cone type shape this way. So I'm integrating from my starting y value of 2 to my height of 5. And there is no space or gaps, so this is going to be a disk method, which means that my volume formula is pi integral 2 to 5 of r squared, where in this case my radius is this square root of y minus 2. Oh no. Better, helping with the volumes and remembering them. Got it. This one right here. So let R be the region bounded by blank and blank. So the region R is the base of a solid where each cross-section perpendicular to the x-axis is a square. So again, we are thinking of a volume equals the integral of s squared, because that'll be the sides of our square. So it's bounded by, I'm just going to graph this so I kind of see it. 9 minus x squared. So good for me, if it's bounded by 9 minus x squared, I know that's going to be a quadratic open down with a starting or a max height of 9. So I know this is going to contain the 0.09, and then it's also going to go through 3, 0. So there's my f, and then g of x is 3 to the x. So again, we know that anything to the power of 0 is 1. So that's going to start at 1. And then 3 to the 1 is, oops, 1's down here. 3 to the 1 is 3. And then 3 squared would put me up here at 9. So I need to know, like, where they intersect. So my cross sections are perpendicular. So if this is the x-axis, they're perpendicular to the x-axis. So here's my R. So that means that my cross sections are going to be squares where it's top minus bottom. So the top curve is always f of x. The bottom curve is always g of x. So when I set up my volume, it's going to be the integral of y1 minus y2. And then all of that squared. And we're going to go from 0, because that's where they start, to whatever that point of intersection is. So 1.6649. Now what's nice is this x is going to be stored in my x. So if I hit like the x key here, that x value is stored there. So when I set up my integral, I can do 0 to x, because that x value is stored there. Or if it makes you nervous, you can just type in that 49, and then parentheses, alpha y equals y1 minus alpha y equals y2, because we stored f and g in there. I put them in parentheses so I can square it, because again, a side of a square is squared. So like base times height, where this is the base and the height. Uh-oh. So maybe they have an error. I mean, I don't know how it could be anything else. I'm going to send a picture and ask my other math teacher friends. has to be.